Hello and welcome to another video. In this video we're going to be going over length of longest subarray with at most k frequency. And in this problem you're given an integer nums and an integer k, and the frequency of an element is the number of times it occurs in the array, and the array is called good if the frequency of each element in the array is less than or equal to k. Return the length of the longest good subarray of nums. A subarray is a contiguous, non-empty sequence of elements in the array. So in this first example it's this right here, 1, 2, 3, 1, 2, 3. Because for k equals 2, the most you can have for any one value is appearing twice, and all the values are 1, 2, 3, so this is literally like the biggest it can possibly be. And there are some other ones that are also good. In example 2, k is 1, so the biggest subarray of, if you only have elements 1, 2, you can only have one of each, so either like 1, 2, or 2, 1, and so that's length 2. And in the last one, k is 4, and every number is 5, so the biggest subarray you can make is just 4 5s. So I talked about this yesterday. You're looking for, when you're trying to figure out how to do this, you're looking for this. If it's a contiguous subarray, you basically want to start with a sliding window. And this is like a pretty easy sliding window one to figure out. So let's go through this first example one. So let's just say we have an array over here, and let's have these numbers. So let's make this kind of big, and let's put in these numbers. So 1, 2, 3, 1, 2, 3, 1, 2. So all we really need to do is just make sure that as we go through our window, the frequency of the current element we're on is not more than k. And if it's more than k, we can just shrink our window. So it's a really straightforward one. So we can start like here. Let's make another one. And we're just going to have it's also pretty straightforward to figure out that you're going to want a hash map of counts and a result. So we'll have some result variable, and we'll have a hash map over here. So our result will start off as 0. So basically what we're going to do is, and for this sliding window, the template you want is grow window, shrink to fit constraint, and then do something with the size. Do something here with valid window. And that's pretty much it. So let's kind of walk through these things. So first, we're going to go through this element here. So we'll have 1 with a count of 1. And we check, is that 1 greater than k? No, it's not. So this is a valid window, so we don't need to shrink. So we're going to shrink until the count of our current integer is less than or equal to k. It's already less than or equal to k, so we don't need to shrink. And then our result to do something here is just update the result. So our result's 1. Then we're going to go over here. We're going to move our right pointer, and we'll have 2 now is 1. Do we need to shrink? No, we don't, because 2 is already less than k, so now our result is 2. Then we keep growing, so we get a 3 with a count of 1. Do we need to shrink? No, because 3 is already less than k. It only occurs once, so we don't need to shrink, so we'll just make it 3. Then we go over here, so now 1 has a count of 2. Is that count greater than k? No, it's not, so we don't need to do anything, and our result is now 4. And then we can just speed this up a little bit. So 2 and 3 will also be put in here. So 2 and 3 will also be put in here. Oh, whoops. 2 will have a count of 2, 3 will have a count of 2, and as we do this, we update our result. So now our result will be 6, because this is all valid so far. And now finally we come over here. So we come over here, now our count of 1s is 3. And now we need to shrink our window, because the count is too big. So we're going to keep shrinking until the count of 1s is no longer 3, and we're going to shrink by decrementing whatever the left is. So we're going to decrement this. So this is 1, so we're going to decrement 1 from here, and now we have 2 1s. Now our window is valid again, and we move our left as we decrement, and this is length 6, so this is also a valid window. So we're good, we don't need to shrink it anymore, and then we just update our result. Then finally we update this to 3. And then this is too big again, so we need to shrink from the left. Now it's not always that this is going to be a 2, like you might have to shrink a lot. So you just keep shrinking until the count of the current number you're on is less than or equal to k. In this case it works out where it's always the first one, but that's not necessarily the case. So we're going to shrink from the left, so we're going to decrement this count to 2. We're going to move our left, and now our result is 6 again, but it's already 6. So then we just return 6. And that's kind of how it works. Pretty easy. Just a standard sliding window. And so I'll go over like the template you can use for 90% of your problems in the code. So first you want to start with a result variable. Depends on what you want. If you want to maximize it, you can just make it 0. If you want to minimize it, you can make it like infinity or something. Then what you want to have is the left pointer. So this is pretty much always going to be at 0. And then you need some kind of data structure, like whatever you need, either a sum or a count or whatever. This is going to go here. So in this case, we need a hash map. So we need a map of integer to its count. So integer, integer. And we'll call this like count or something. And this is going to be a new hash map. So there. Then our loop is pretty much for almost all sliding windows. We can just have our right pointer that we just loop through. So for right equals 0, or int right equals 0. Right is less than num's length. So this is going to be like these two lines, and this loop is going to be the same for like 90% of sliding window problems. This should be less than. So here's our left and here's our right pointer for our sliding window. Now what we need to do is we need to take our current value in, whatever you need, add it to the sum, add it to the hash map, some kind of thing, right? And that's here, grow window and use our value. So what we need to do is we need to update the count of our current value. So we can say counts put, and then this is going to be counts, and it's not necessarily in here already, so we'll just do like a getter default, which is like kind of like a default dict in Python, same kind of thing. So we get our default nums right, and if it's not there, we'll do 0, and we increment it by 1. Then we basically need to say, while the count of this number is greater than k, let's keep shrinking our window. So that's also going to be a very standard, you just have a while loop, basically while window too big, shrink window on some constraint. So while counts.get nums right, and we don't need to do a getter default because it's always in there because we already initialized. So if this is greater than k, then we need to shrink the window. So to shrink the window, we need to take whatever's in the left and decrement that count. So we can say counts put counts get nums left. So we want to take that and then we want to decrement it, so -1. And where we actually want to put that is also going to be nums left, right? So essentially, if you look here, so we're basically saying take the key that's on the left and decrement it by whatever its value was. So this is going to be this. Yeah. And then what we need to do is we need to actually do the actual shrinking. So we'll do left ++. And then, so now at the end of the while loop, our window is valid. So this is basically going to be the same format always. Have a while loop to shrink your window. Then down here, your window is valid. Then you can do some kind of, like if you need to do anything afterwards. And what we need to do is maximize our result. So we can say result equals math.max. This is also pretty standard. If you're trying to like look for what's the biggest window I've ever had, you just say result is the maximum of the old result, and right minus left +1 is the length of our current window. Because if we have a pointer here and here, let's say, our window is 1, 2, 3, 4, 5, 6, so 7 minus 2 plus 1. So it's, yeah, the right pointer minus the left pointer plus 1 is the length of your window. Yeah, and we return the result. And that's pretty much it. So like, I'd say 80% of this code is the same for all sliding window problems. Then you just change the constraint that like you have a map or a sum or whatever here, and you have something different here, and then you figure out the constraint for the while loop, and then this is basically always shrink and increment left. So let's see what we get. Oh, I need int. Probably misspelled something. Let's see. Put cannot be applied to the given type, so let's see. Counts.getter default. Oh, right, we need to put it as the key. So the key will be nums, right? Okay, hopefully that's good. Very nice. And Java is a bit more verbose, but not that bad. Okay, and so we had it work, and then we can do the runtime. So runtime for pretty much all sliding window problems, not all, but the majority. The goal is to do a one pass, right? So this is going to be O of n. Like it's all pretty much always linear time. You might have to do something else. You might have to do like a sliding window with a binary search or something, but in most sliding windows, it's just linear time. And space for most sliding windows, if you don't need a hash map, is going to be O of 1 because you just have a left and a right and some variables. But in our case, we do need a hash map, so this is O of n. But regardless, pretty standard problem. I'd say if you've done a decent amount of LeetCode, this is towards the easy end, and this should be like pretty recognizable pretty quickly. So yeah, if you have any questions, let me know. And as always, if you like the video, then please like it and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.